Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay, back with yet another Algebra 1 video for you all. And today we're going to look at how to find solutions for the standard form equation in Algebra 1, obviously. This is to wrap up our quadratics unit at the end of this course. So before we get into today's lesson, please make sure to do 4 things. Hit that like button, turn on post notifications, hit that subscribe button. Also, feel free to leave a comment down below. So as I was saying, we're going to be covering how exactly to calculate for the solutions within an equation. So I'll show you the steps of actually calculating it, the computational steps of the standard form equation, understanding what these solutions actually represent on a parabola, and also looking at a specific word problem, kind of like a real-life application of this concept. So let's jump right into it. So let's start off by identifying what exactly are the solutions of a parabola. What do they represent? So the solutions of a parabola, they're also known as the zeros of the equation. And the reason being is that a solution of a quadratic function is where the parabola actually intersects the x-axis. So if you think about your parabola or your giant U that goes infinitely in one direction, it's going to intersect the x-axis at one point, or it might not at all. So that determines how many solutions or zeros that you're going to have for your x value. So you can have one solution, two solutions, or 0 solutions where x equals 0. So remember, your zeros are essentially your solutions, and that means that your solutions are whenever x equals 0. Whenever your parabola intersects the x-axis, those points are always considered your solutions to the equation. You can have one solution, the parabola only crosses it once. Essentially, its vertex must be on the x-axis in that case. You can have two solutions where it essentially intercepts the x-axis on obviously those two different ends, or 0 where it doesn't even touch the x-axis, where it's always above the x-axis. So you can calculate for your x-intercept by setting your y equal to 0. So remember how I talked about whenever y is 0, that's when you find your x-intercept, vice versa. When x is 0, you find your y-intercept. So you set your y to equal to 0 in your equation. That's how we get the whole equation of, ax squared plus bx plus c equals 0 to try and find the solution. And no solution parabolas, essentially the parabolas that are above the x-axis, never touch it. They have something called imaginary solutions. They don't have any real numbers like 1, 2, 3, -1, -2. They don't have any actual numbers that represent them. However, they have an imaginary solution set which was inspired by this whole concept. So there's a whole new set of numbers called imaginary numbers, essentially I, and you're going to learn about that in Algebra 2. So let's take a look at the number of solutions. How do we see this graphically? So graphic examples. So let's take this x-axis here in this example. One solution case would be this example right here, essentially where the parabola is the vertex of the parabola is sitting on the x-axis. So only one point is actually touching the x-axis or intersecting it. So this is one solution. All right, next example, we're going to have a parabola, except that it's a little bit pushed, like almost dragged downwards a little bit more. And in this case, it's obviously going to be intersecting at 2 different points. So that means 2 separate solutions. This is the maximum amount of solutions a parabola can have. So this is 2 solutions. And then, of course, for our last example, this is going to be a 0 solution set because the parabola will never touch the x-axis. If it's a downward-facing parabola and it's below the x-axis, then it's never going to touch it. Same thing with an upward-facing parabola. If it's up above it, then it's never going to touch. So this is going to be a no solution. And obviously, this is going to lie within the imaginary number set. Now let's take a look at another important zero product property. This zero product property is very important in identifying how to factor out your standard form equations to actually solve for x. So factoring equations. So the zero product property states that for all numbers a and b, if a, b equals 0, then either a equals 0 or b equals 0. So let's take this example here. If we know that a times b equals 0, we know that a equals 7, then we automatically know that b equals 0. Vice versa, if b equals 7, then we automatically know that a equals 0, or both a and b can equal 0. So whenever anything is multiplied by 0, it's always going to be 0 in that case. So that's a whole concept here. So let's find the solutions of the equation. We're given this equation, x minus 9 times 5x plus 2. This is a little bit easier because it's put in factored form. We'll also take a look at a standard form where we have to factor it out and then look at the solutions. But if you're given this example here, we take the property of a, b, right? A times b. If a times b equals 0, then either a equals 0 or b can equal 0. So in this case, if x minus 9 is our a and b is 5x plus 2, that means that x plus 9 can equal 0, or 5x plus 2 can equal 0. So in this case, we see that x minus 9 equals 0. Simple equation, x equals 9. And then 5x plus 2 equals 0. 5x equals negative 2. X equals negative 2/5. So x can equal either 9 or negative 2/5. So this solution set, this parabola essentially has two different solutions. You take apart the two separate factors here, and they're both going to be set equal to 0. That's the whole property of this, the whole purpose. That's to find out what your x-intercepts are with your y equaling 0. All right, let's take a look at another example. So let's find the solutions of this equation. We're given this equation here, except it's in standard form. So now we're going to have to actually do a little bit more work, grunge work essentially. So x squared minus 16x plus 64 equals 0. Let's start off by identifying what are some common factors here. So what two numbers multiplied together equals 64 and also add up to negative 16? Well, the first thing that pops up is 8. And we know that since it's a negative 16, it has to be 2 negative 8. So this is going to be a perfect square. So x minus 8 times x minus 8 equals 0. And this is a very interesting example here. We know that this is going to be our a and this is going to be our b. So we're going to set both of these equal to 0. Now, if we think about it, x minus 8 and x minus 8, that's the same exact thing. So we know they're going to equal the same exact solution, which is x equals 8. So in this case, we don't have this extra solution here. It's just 8. So this would be a one solution set. Meaning that this parabola, we've just calculated that this parabola's vertex is going to be sitting on the x-axis itself. All right, now let's move on to a final word problem to really round it out. So this word problem is going to be all about a swimming pool. So a swimming pool has a length that is twice its width. The deck around the outside has a uniform width of 2 feet. So if you think about the actual swimming pool itself, you have this little walkway that goes around it. It's 2 feet in width. The total area of the pool and the deck that borders it is 96 square feet. What are the dimensions of the pool itself? So let's take a look at this problem. Let's find out what the solution is and let's solve it. So we're given this pool here, this yellow, marked in yellow. That's the actual pool itself, filled with water. And then, of course, this green is going to be marking the whole entire contraption that we're looking at, including the walkway, essentially. And now we're going to map out essentially what these different points are. So we know that first thing that we were given is that the pool's length, if we refer back to the problem, the pool's length is essentially twice its width. So I'm going to put this in terms of x because we want to put this in terms of a quadratic function, essentially. So we know that our width is here. It's going to be x of the pool specifically. And that makes our length here 2x because it's twice the size of x. And then obviously that last bit of information we were given is that the walkway's width, the distance between the pool and the outer edge of the green, is going to be 2 feet. And we're just concerned with the area of the pool itself. So what exactly is this area here? That's what we're looking for. So first we can identify essentially what we know about the pool. So we know the entire contraption is 96. That's the area. So let's calculate what the dimensions of this whole entire contraption are. So we know that the width of this whole contraption, including the deck and the swimming pool, we know that since this is 2 feet here, and it's also 2 feet on this side here, we know that we're going to be adding 2 feet to the width here. So if we take a look at this, we'll start off with the width here. So x here. So we know that x is we're going to be adding 2 above the x, essentially at 2 feet on top. And we're also adding that 2 feet on the bottom. So we're adding 4 feet in total to get that extension on both sides with the border. So that means that the width is going to be equal to x plus 4. And then obviously the length, we're also adding 2 feet on the right-hand side and 2 feet on the left-hand side. And that's 2x for the length. So it's going to be 2x plus 4 for the whole contraption. Next thing that we're going to do is we're going to set this equal to our area. We know that the area is going to be 96 square feet. So that means 96 equals x plus 4, our width, times our length, 2x plus 4. All right, now we can just merely factor this, FOIL this out, and then we can start to factor it out, group it, and find out what our solutions for x are. So first thing that we're going to do is we're going to multiply this out to get our standard form equation, to actually find out the total non-factored out form of what the area is. So we're going to multiply this out. So x times 2x is 2x squared. 4 times 2x plus 4 times x is going to be 12x. So plus 12x. And then 4 times 4, that's going to be 16. Now remember, if you refer back to our previous video, whenever it comes to these extensions, we can take a look at the 2 feet, the 4 feet essentially that we added to the width and the length. We know that that 4 feet times that 4 feet, that's all of that's going to be part of the border essentially. All that width and that length, the 4 is going to be that length and the 4 is going to be the width of the border. So essentially all of that's going to be a part of the border, so we can automatically subtract that out from the equation. This constant here is always going to get subtracted out because it's only representative of the border. It's a constant. It doesn't have x in it. So we're going to subtract that. And we're left with 80 equals 2x squared plus 12x. Next thing we're going to do is take out the greatest common factor. So that's 2. We're going to divide both sides by 2. We get 40 equals x squared plus 6x. We're going to subtract 40 from the left-hand side to get this equation equal to 0. So x squared plus 6x minus 40 equals 0. And then, of course, we're going to try and factor this out in this case. So what are some factors of negative 40 that will add to positive 6x? So we know that 4 and 10, they'd multiply to 40, but what are the combinations? Well, we know that 6x is positive, so the larger number has to be positive, which means that 10 has to be positive. So the factors are x minus 4 times x plus 10 equals 0. Now we have our two solutions. We set them both equal to 0, and then we'll calculate which one's the actual solution. So we know that x minus 4 equals 0 and x plus 10 equals 0. Well, right off the bat, we know that since x plus 10 equals 0, x has to equal negative 10 for the solution. You cannot have a negative distance. Therefore, this is not a solution. So then the only thing that's left is x minus 4 equals 0, and we're left with x equals 4. So the dimensions are x equals 4, which is going to be our width here for x, and obviously our length here, 2x length, is going to be 8 because it's twice x, twice the width, 4. So the total area of the pool is essentially 32. Alright everyone, well I hope you guys enjoyed this video here. This has been the eCoreAcademy e-learning platform. Just please make sure to like and subscribe down below if you haven't already. Leave a comment down below, and also feel free to share and turn on post notifications. Check out our website at www.ecoreacademy.org. We have full courses there for free, so please check that out. Email us at eCoreAcademy@gmail.com, and check out all of our socials: Pinterest, Facebook, Twitter, Instagram, and TikTok, all linked in the description box down below. Well, that'll be it for today's video. I hope you guys enjoyed. This has been AJay Raj, and I'll see you guys in the next one. Peace.